Let's talk about something you're doing right this very second. Reading. I mean, it feels totally effortless, right? Almost like breathing. But what's actually going on inside your brain is this high-speed, incredibly complex performance. So today, we're going to pull back the curtain on the neuroscience of reading just a single word.
Seriously, have you ever stopped to think about it? As your eyes scan these words, how does a jumble of letters turn into a complete thought in your head, almost instantly? What is your brain doing right now? Well, that's the fascinating mystery we're about to solve.
You know, scientists actually have a name for this amazing feat: lexical access. One researcher even called it the magic moment. And that's exactly what it is. It's that instant where your brain takes a string of letters, like MAGIC, and connects it to what it means, how it sounds, and its job in a sentence. We're going to break down how this magic trick happens in a fraction of a second.
Okay, so to understand this whole process, we have to start where it all begins, with your eyes. The physical act of just looking at the text is the first clue in our investigation, and believe me, it is not nearly as straightforward as you'd think.
So here's a huge misconception. Most of us imagine our eyes just gliding smoothly across a line of text, like a camera panning across a landscape. But the reality? It couldn't be more different. What's actually happening is a series of tiny, frantic little jumps and stops.
And this is where two cool terms come in. Those little jumps are called saccades, and the pauses, those are called fixations. And get this, it's only during the fixation, that super brief moment of stillness, that your brain is actually taking in any information. During the jump itself, you see absolutely nothing. And these saccades are just unbelievably fast. We are talking 20 to 60 milliseconds. That's thousands of a second. It's such a quick blur of motion that our brain just completely edits it out of our experience. We don't even know what's happening.
But this is where the real work happens. During that little pause, the fixation, in just 200 to 250 milliseconds, that's about a quarter of a second, your eye stops, sucks in about 15 characters of text, and zips that snapshot over to the brain. Just think about that. Every single word you've read so far has been pieced together from these tiny, high-speed snapshots.
All right, so the eye has gathered all the data. The next big question is, how on earth does the brain sort through it all so fast? Well, it turns out it has a playbook, and it's full of some really brilliant shortcuts.
The first rule in this playbook is actually pretty simple. Your brain totally plays favorites. It does not treat every single word you see with the same amount of effort. Nope. Some words get the full VIP treatment.
This is called the word frequency effect, and it's a huge deal in reading speed. Your brain recognizes super common, high-frequency words like the, and, or is almost instantly. But a rare, low-frequency word like heresy, well, your brain has to work a lot harder, and it takes more time. It's kind of like the difference between spotting your best friend in a crowd versus some distant cousin you only saw once.
Okay, so the second trick in the playbook is all about teamwork. You can think of it like this: words have friends, and seeing one friend makes it way easier to spot the others in their group. This is a perfect example of something called semantic priming. If your brain processes the word doctor, it's like it lights up a whole network of related ideas. So when the word nurse shows up next, its little recognition system is already warmed up and ready to fire. You recognize it way faster than if you'd just seen an unrelated word like, say, butter. And this isn't just some minor little quirk. Researchers actually consider semantic priming to be, and I'm quoting here, one of the most robust and important findings in the entire field. It just goes to show that our brain is constantly predicting and getting ready for what might come next.
Okay, so the brain uses frequency and context to speed things up. But what happens when it faces the ultimate challenge? Words that have identical twins. Words that look the same but mean totally different things.
So let's read the sentence together. The man was not surprised when he found several bugs in the corner of his room. Now, just pay attention to what your brain just did with that word bugs.
So what popped into your head? Insects, right? Or maybe spying devices. The context of the sentence, the corner of his room, probably pushed you towards insects. But how did your brain make that call, and how fast did it do it?
A really famous experiment figured this out. It found that for a brief, unconscious instant, the first fraction of a second after you read bugs, your brain actually activates both meanings. The ideas for ant and spy both light up for a second. It's only about 200 milliseconds later that the rest of the sentence kicks in and shuts down the wrong meaning, leaving only the correct one. Isn't that wild?
So how do we put all these pieces together?
The eye movements, the frequency effects, the priming, the ambiguity, how does it all work? Well, scientists have proposed a few different models to try and crack the code.
Here's a super quick look at 3 of the big ones. The serial search model basically says your brain flips through a mental dictionary that's sorted by how common words are. The logogen model imagines every word has a little counter just waiting to go off once it gets enough clues. And then there's the IAC model, which pictures this huge web where letters light up possible words, and they all compete until one winner emerges.
You know, when you put it all together, one thing becomes crystal clear. What feels like a simple act of seeing is anything but. Reading is this active, dynamic performance. In the time it takes you to blink, your brain runs this incredible ballet of prediction, recognition, and selection, all happening completely beneath your awareness.
Which brings us to a final thought. The next time you effortlessly scan a sentence or just get lost in a good book, are you going to think of it as just reading? Or are you going to remember the hidden, high-speed magic happening inside your own mind?